Hello student, welcome to all of you in the next physics lecture. Now we have to see here the in the chapter measurement we have to see the dimension. What is meant by the dimension and how we can find out the dimension of the number of physical quantities. In this chapter, first we have to see the fundamental quantities and the derived quantities. Fundamental quantities means what? Those physical quantity which does not depends upon the any other physical quantities for their measurements are known as a fundamental quantity. Fundamental quantity, that means which does not depends upon the any other physical quantities, known as a fundamental quantities. These are the only seven physical quantities, which are nothing but what? Length, mass, time, temperature, electric current, intensity, and the amount of substance. And the SI unit is, you know that this well. Okay. Now, what is meant by the derived quantity? Those physical quantity which can be depends upon one or more any other fundamental quantities for their measurement are known as a derived quantity. Okay, then the derived quantities are nothing but the force, momentum, impulse, acceleration, velocity. That means those physical quantity which can be derived in such a way that, like the force is equal to mass into acceleration. Then again acceleration is nothing but what? Velocity upon time. Again velocity is nothing but what? Displacement upon time. And this is the derived quantity. Okay, now if you have to know this fundamental quantity and the derived quantity, then from this we can uh, learn this the next topic, the dimension. This is very important, and for the 12th this dimension you have to uh, find out the dimension of the various physical quantity. 12वीमध्ये सुद्धा तुम्हाला कुठल्या तरी कॉन्स्टंटचे डायमेन्शन काढायला सांगितले जातात. त्यामुळे डायमेन्शन कसं काढलं जातं हे सर्वांना यायला हवं. ठीक आहे. आणि म्हणून आपण आता डायमेन्शन म्हणजे काय ते पाहणार आहोत. ओके. What is meant by the dimension? The dimension is nothing but a physical quantity, the powers to which rises, powers to which the fundamental units which must be rises in order to obtain the unit of that physical quantity. This is nothing but the dimension. ही डेफिनेशन जर सांगितली तर बऱ्याच जणांना ती समजत नाही पहा. मग आपण ज्यावेळेस एक्सपेरिमेंटली ही डेफिनेशन ज्यावेळेस पाहणार आहोत त्यावेळेस तुमच्या लक्षात येईल की डायमेन्शन ऑफ द फिजिकल क्वांटिटी विच आर नथिंग बट व्हॉट? द पावर्स टू विच द फंडामेंटल युनिट्स which can be rises, powers of that fundamental units which must be rises, but how? In order to obtain the unit of that physical quantity, and these are known as a dimension of the given physical quantity. Now we have to see here the how that dimension can be the we have to find out. First of all, we have to take here the physical quantity. Suppose the displacement. First we have to see here the displacement. Then displacement is nothing but the distance which can be measured in a given direction. Then the fundamental quantities are L, M, and the T. These are the fundamental quantity. Then powers of that fundamental quantity which can be rises in such a way that to obtain the unit of that physical quantity. Therefore, displacement is nothing but the length. There we have to take here the L1. There is no mass, take here 0. No time, take the 0. This is the dimension of that displacement L1, M0, T0. हे डायमेन्शन वाचायचं कसं पहा? Displacement, dimension of the displacement L1, M0, T0. Suppose we have to next quantity we have to take here the velocity. Velocity. This is the next quantity. Then the velocity is nothing but what? This is the rate of change of displacement with respect to time. This is nothing but the displacement and upon the time. That means the displacement is nothing but what? This is the length and time for the t. Then from this we can find out the dimension of that velocity is nothing but what? L, M, T. These are the fundamental quantity. Rises the powers of that fundamental quantity in such a way that obtain the unit of that physical quantity, that is the velocity. Then here L, therefore we have to take here L1. Mass, here is no mass, then take here 0. But here time, but which is in denominator, therefore take upward side, then this is nothing but the -1, and this is the dimension of velocity L1 m0 t minus 1. Then again acceleration, आपण अशा क्वांटिटी घेतोय की त्या एकमेकावर डिपेंड आहेत. व्हेलॉसिटी डिस्प्लेसमेंटवर डिपेंड आहे, ॲक्सलरेशन व्हेलॉसिटीवर डिपेंड. But you have to know this definition of that acceleration, basic terms. Acceleration is nothing but the rate of change of velocity with respect to time. Therefore we have to write here the acceleration is nothing but the velocity upon time. Then again we have to write here the velocity is nothing but what? We have to write here L by t. Okay, L by t. Then again this time is the t. Therefore we have to also write here L by t into this 1 upon t, therefore L upon t square. Okay, therefore dimension of this L upon t square is nothing but L, m and t. Then L is here 1, m there is no m, 0, therefore t raised to 2, this is the denominator side, take upward side, then this is the -2. L1 m0 and t minus 2, these are the dimensions of, okay, these are the dimension of the acceleration L1 m0 t minus 2. This is the dimension of acceleration L by t square. From this definition, म्हणजे तुम्हाला ह्या डेफिनेशनवरनं हे डायमेन्शन कसे काढायचे हे जमलं पाहिजे. ॲक्सेलरेशनची डेफिनेशन माहिती पाहिजे, रेट ऑफ चेंज ऑफ वेलॉसिटी विथ रिस्पेक्ट टू टाइम. Velocity means what? L by t. Again time t, that means this is the L by t square, therefore L1, then m is not there, therefore m0, t is here, t square, but this is the denominator side, therefore taking upward side, the t raised to -2, L1 m0 t minus 2. This is the dimension of the acceleration. Okay, now we have to take here the next dimension, that is the force, and this is the very important one, the dimension of the force, which is used in all the any other terms. We have to find out the dimension, then you know the first the dimension of the this force. Therefore we have to find the dimension of the force. First of all, we have to know that this, what is meant by the force. Force is nothing but what? It is the product of mass into acceleration. Mass into acceleration. Therefore we have to take here mass, that is nothing but the m, and acceleration, we know that mass acceleration we have to find out here the L by t square in previous terms. This is the L upon t square. Okay, the mass m and acceleration is nothing but what? L upon t square. From this we can write the dimension. Okay, L is here, therefore we have to take here L1. Okay, mass is there, therefore we have to again here m1, and t denominator side, take upward, then t raised to -2. Then the dimension of the force are L1 m1 t minus 2. This is the very important. Okay, then the next term is the work done, that is the work, also which is always in the form of the energy. Work is always in the form of the energy. Therefore work is nothing but what? It is the product of force into displacement. Work is nothing but the force into displacement. Then we know that the dimension of the force, what is the dimension of the force? We have to find out here L1, then m1 and t minus 2. Displacement is nothing but what? Length, therefore L1 m0 and t also 0. Then you can use the index rule, and that index rule is nothing but, you know that base same multiplication, then there is the addition of the powers. If there is the division, then there is the subtraction. Then add the power of this same, this base, therefore here L1, this is the L2, then 1 plus 0 also 1, -2 plus 0 -2, and this is nothing but the dimension of the work L2 m1 t minus 2. Okay, then we have to take the here a lot of physical quantities, we can find out the dimension. One more important this quantities like the momentum. Next term is the momentum. This momentum is nothing but it is the product of mass into velocity. product of mass into velocity. Then again we have to write here mass, dimension of the mass. If you have to write in this way for the trick, this mass for we have to write simply m here, okay, and the velocity is nothing but what? Rate of change of displacement with respect to time, therefore L upon t. Then from this we can write here the dimension of L is here L1, m is here m1, and t denominator take up both side, then it is also minus 1. L1 m1 t minus 1. This is the dimension of the m momentum. And next term is the impulse. This impulse is nothing but what? It is the product of force into time. Then we know that the dimension of the force, what? L1 m1 t minus 2. This is the dimension of the force. If you have to समजा तुम्ही फोर्सचे डायमेन्शन विसरले, मग तुम्ही कसं करणार? मग तुमच्या लक्षात आलं फोर्स म्हणजे काय? F is equal to ma, m as it is acceleration means what? This is the velocity upon time, L by t upon t म्हणजे L upon t square. मग हे तुमच्या लक्षात आलं की L1 m1 टी टेक अप वर साईड देन -2. अशा पद्धतीनं सुद्धा तुम्ही ते डायमेन्शन फोर्सचे कुठली जर तुम्ही विसरलात तर अशा पद्धतीने हे फॉर्म्युले तुमचे चांगले पाठ पाहिजे, डेफिनेशन तुमच्या सगळ्या बेसिक टर्म्स चांगल्या पाहिजेत, मग तुम्हाला हे डायमेन्शन काढायला काही अडचण येणार नाही. मग आपण फोर्सचं डायमेन्शन दिलं L1 m1 t -2. टाईम म्हटल्यानंतर L0 m0 आणि फक्त टी म्हणजे टी रेस टू काय येणार या ठिकाणी 1 येणार या ठिकाणी लक्षामध्ये. मग बेस सेम मल्टिप्लिकेशन पॉवरची ॲडिशन करायची, मग काय येणार 1 + 0 L1 येणार, मास 1 + 0 1 येणार, -2 + 1 काय येणार त्या ठिकाणी -1. therefore dimension of the impulse L1 m1 t -1. मग कधी कधी असाही क्वेश्चन विचारला जातो की शो दॅट द डायमेन्शन ऑफ द क्वांटिटीज मोमेंटम अँड इम्पल्स आर द शो डायमेन्शनली. तुम्ही ह्या पद्धतीनं मोमेंटम इज द मास इंटू वेलॉसिटी and impulse is nothing but the force into time, and the dimension of the both L1 m1 t -1. Sometimes as the which quantities have the same dimension, then the pair of this momentum and impulse have the same dimension L1 m1 t -1. These are the important dimensions for you. Okay, now we can find out the dimensions like the physical quantity, power, then intensity, potential, like the volume, density. You know that this volume, suppose you have to find out the dimension of the volume, length into breadth into height, then this is nothing but the what? L cube. Therefore dimension is nothing but what? L cube, L3 m0 and t0. This is the dimension of volume. Then the volume, we have to find out the dimension of the density. Now you know that the formula for the density is nothing but what? This is nothing but the mass per unit volume. Okay, and therefore mass m and volume is nothing but what? L cube. Then the dimension of the densities are L, take this up both sides, L -3, m as it is m1, and t, there is no t, therefore time is in here no, therefore t raised to 0, L -3 m1 and t0. This is the dimension of the density. If you have to understand well, then we have to find out in the next lecture to application of the dimensional analysis, show that to convert the factor which are convert the one unit into the second unit, MKS and the CGS, to determine the conversion factor between the two units of the same physical quantity, like the 1 Newton is equal to 10⁵ dyne, or 1 Joule is equal to 10⁷ hours. We have to see the next lecture. Okay, stop here.